Good morning. My name is Shelley Joy, and I present today an alternate theory to current paradigms of consciousness. A paradigm that is based upon Karl Pribram's holonomic brain theory and David Bohm's implicate order. A little background. I have degrees in electrical engineering, philosophy, and consciousness studies. All share a common thread in my early fascination with how to communicate with invisible radio energies. In short, I was a geek. So I learned Morse code and electronics and obtained an amateur radio license at the age of 12. With the help of my CIA neighbor, I built a working linear ion accelerator my senior year of high school, with which I won a Northern Virginia science fair, and this likely led to my being accepted for admission to MIT. But in college, though I started out in physics, I ended up in electrical engineering. But the summer before my final year of electrical engineering, it happened to be 1967, the summer of love. Sometime in July that summer, I found myself taking a large dose of LSD on a clear, star-filled night on the beach just south of Big Sur. As I wandered around beneath the stars, a new and amazing cosmos opened up, and I felt I had become one with the star maker. My theory is that these amazingly complex hydrocarbon molecules of lysergic acid diethylamide, breaking down in the warmth of a coursing ionic bloodstream, radiate a unique electromagnetic energy spectrum which interact with, resonate with, and drive the blood's magnetic plasma. At least that's what I thought happened that night. What happened that night changed the arc of my life toward one of exploring the relationship of electromagnetic theory with consciousness. Now for a discussion of holoflex theory. First, I propose that consciousness manifests as tunable radiant energy. Pribram found holonomic information encoded with an electromagnetic flux in the cranium. I agree with David Bohm that consciousness resonates between two domains, a space-time explicate order and the non-dual implicate order. And finally, the source of consciousness is to be found in the non-dual implicate domain where space ends, at the center everywhere, below the Planck length threshold of 10 to the minus 35 meters. David Bohm, who pioneered the subquantum dimensions of the implicate order, was fascinated with plasma, one of the four fundamental states of matter. His dissertation at UC Berkeley presented an entirely new mathematical model of plasma. Plasma constitutes over 99% of the matter of the universe and is the primary constituent of cosmological structures, such as stars and gas clouds. And for the next 40 years, Bohm worked tirelessly, trying to elicit an ontological understanding of the plasma state and what it might mean for physics, cosmology, and human consciousness. Bohm's biographer David Peat tells us, as Bohm studied the plasmas, he became struck by their extraordinary nature. At every scale, both microscopic and intergalactic, these plasma entities began to take on for him the qualities of living beings. When Bohm introduced an electrical probe into the plasma, a charged sheath quickly formed to neutralize the probe, as if the plasma were protecting itself. To Oppenheimer's surprise, Bohm put forth an entirely new theory of the plasma state, supported with a mathematical model. Bohm's discovery was immediately put to use by Oppenheimer's team to separate U-235 from U-238, a critical step in the effort to construct a nuclear bomb. At that point, Bohm's dissertation was classified top secret, and it was only with considerable effort that Oppenheimer was able to persuade the university to grant Bohm a doctorate without publishing his dissertation. Here we see the young physics professor David Bohm at Princeton in 1949, a neighbor and friend of Albert Einstein. At the time, Bohm was writing a 600-page textbook he called simply Quantum Theory. 30 years later, now chair of theoretical physics at the University of London, and after 20 years of metaphysical dialogue with J. Krishnamurti, Bohm writes, "Let me propose that consciousness is basically in the implicate order." So what does Bohm mean by the implicate order? Bohm had arrived at the conviction that the universe consists of two distinct domains, an implicate order and the explicate order. I'll discuss these in detail soon, but first I want to introduce the other half of holoflex theory. Karl Pribram, who passed away in 2015 at the age of 95. He was the author of well over 700 publications, and he continued to teach and lecture well into his 90s. Since the 1940s, Karl had been carrying out experiments in search of the mysterious Engram, the location of memory storage within the brain. But he and his colleagues were unable to discover a specific location for memory storage. After years of research, Karl published his holonomic brain theory. In a long series of experiments, he discovered three-dimensional electric fields within the space of the dendritic webs of the cerebral cortex, depicted to the right in the figure. Karl's extensive lab data suggested evidence of holographic field transformations as the fundamental mechanism in perception, and provided proof that memories are not stored locally. In mapping electric potentials within the cerebral cortex, Karl discovered that when coefficients of identical voltage are connected, a contour map appears. He called these patterns Holoscape contours. In 1964, Pribram read a paper on holograms and immediately noticed how holographic patterns were similar to those appearing in the Holoscape contours that he had discovered in the brain. In a paper on holography, Pribram learned that the mathematics of the Fourier transform describe a natural process in which there is equivalence between two dimensions or domains, the frequency domain and the time domain. He began to suspect that brain processing and memory storage might involve the non-temporal, non-spatial frequency domain. This concept became foundational to Karl's holonomic brain theory, a theory which eventually grew to include David Bohm's concept of the implicate order as a possible factor in the memory storage and perception. This picture of David Bohm, his wife Saral, and Karl Pribram dining out in Prague was taken shortly before Bohm's death in 1992. Pribram and Bohm, the quantum physicist and the brain scientist, had become close friends over 2 decades of technical discussion. While Pribram's interest lay in understanding the mechanisms of perception, memory, and consciousness, Bohm was more interested in the ontological reality of consciousness underlying the cosmos as a whole. Bohm and Pribram held a common vision of the hologram as key to understanding consciousness. They also held the Fourier transform as fundamental in the mechanism of information storage in consciousness, both within the brain and throughout the cosmos. Together they pioneered a theory that is quite unconventional, certainly outside of mainstream thought, physics, and neurophysiology, and yet their holoflex theory is coherent and applicable for mapping consciousness and the cosmos. At the heart of this theory are 3 cosmological constants: the Planck length, Planck time, and the speed of light. The first 2 of these values were determined by the father of quantum mechanics, Max Planck, and published in his famous paper in 1900, which actually began quantum theory. Planck used the speed of light and the gravitational constant to calculate the values of what have now become known as the Planck length and the Planck time. To better understand Planck length and of the implicate order, a thought experiment is useful here. Focus your attention upon the small sphere in the center of this diagram, and assume that it has even smaller dimensions within, that it has an inside. Now let's begin moving inward geometrically toward the center. Imagine that as we move toward the center, we are also shrinking in scale as we continue to travel inward by leaps of 10. Eventually we find ourselves at 10 to the minus 15 meters, the diameter of a proton, the core of a hydrogen atom. But shrinking another tenfold, we arrive at 10 to the minus 16 meters, the size of an electron. And eventually we reach the radius of 10 to the minus 17 meters, the size of a Higgs boson. We are now as deep as contemporary measurements have been able to go, at the limit of the Large Hadron Collider. But let us continue moving inward, shrinking toward the geometric center until we reach the very bottom limit of space, the Planck length of 10 to the minus 35 meters. This is the end of the line. We've reached the bottom limit of space, or have we? Bohm doesn't think so, and neither do I, and I quote from Wholeness and the Implicate Order. To suppose that there is nothing beyond this limit at all would indeed be quite arbitrary. Rather, it is very probable that beyond it lies a further domain, or set of domains, the nature of which we have as yet little or no idea. Bohm, going even further, tells us that here at the very bottom of space, reality consists of an actual plenum. Bohm states, what we perceive through the senses as empty space is actually the plenum, which is the ground for the existence of everything, including ourselves. The things that appear to our senses are derivative forms, and their true meaning can be seen only when we consider the plenum, in which they are generated and sustained, and into which they must ultimately vanish. This is strikingly reminiscent of the previously discredited ether concept, a core belief of 19th century physics. Now recalling that the holoflux theory posits consciousness as energy flux resonating between two domains, the explicate and the implicate, the question now arises, what is the relationship between the energy of consciousness within the implicate order and the energy of consciousness within the explicate order? What is the mechanism of information interchange between these two? For an answer, we turn to the following diagram. This diagram, appearing in several of Pribram's published works, indicates the basic relationships underlying quantum theory. Pribram obtained this diagram during a presentation given by the head of the Berkeley Physics Department, Geoffrey Chew, who told Pribram that he had been given it by another Berkeley physicist, Henry Stapp, who himself said that the diagram had been given to him by Dirac. Central to Dirac's diagram is the Fourier transform, the mathematical bridge between the spectral and the space-time domains. And at the very bottom of the diagram, Dirac indicates that it is here at the scale of Planck's constant where the fundamental action begins. A brief review of the Fourier transform is in order. In 1822, Jean-Baptiste Fourier, experimenting with heat flow, discovered a mathematical transformation mapping energy in the two domains. The equation on the left transforms information from the frequency domain into the time domain, and the equation on the right transforms information from the time domain into the frequency domain. Here we see an engineering application of Fourier transform processing. Incoming music is detected by a microphone at the left. At regular intervals, the acoustic wave is sliced by a frequency splitter into 16 distinct frequencies. The amplitude of each frequency is recorded and stored, and thus incoming space-time music has been converted to spectral data. Later, the frequency data is unpacked, mixed, and emerges from the speaker at the right, once more in space-time. The holoflux theory posits that the energy of consciousness operates in a somewhat similar fashion, continually transforming between two domains. Here we see Bohm's implicate order and explicate order within the context of Dirac's diagram. The implicate order lies within the spectral energy region, while the explicate order lies within space-time to the right. Again at the center we see the Fourier transform. But to understand abstract relationships such as these, it is more useful to view them geometrically. In this diagram we see a quantum black hole or Planck holosphere separating space from an interior implicate order. Surrounding the central Planck holosphere we see three isospheres, each providing enormous memory storage capacity. For simplicity, only three isospheres are shown, but in actuality we should consider many, one for each quantum frequency in the virtually infinite electromagnetic radiation spectrum. Each isosphere resonates at a unique frequency fixed by its diameter. Each frequency resonates with the same corresponding frequency within the implicate order. Notice the grid. Each rectangular grid represents one bit of information stored on the isosphere. Let me explain. As a graduate student under John Archibald Wheeler, who coined the term black hole, Jacob Bekenstein pioneered the mathematics of black hole thermodynamics. Bekenstein defined the qubit as the smallest possible storage area in space, having an area of 1 square Planck length. The upper limit to the information that can be contained upon the surface of a specific finite volume of space has come to be known as the Bekenstein bound. As an example, particularly appealing to those of you who may consider blood as a possible conveyor of consciousness, let us examine the possible storage capacity of an erythrocyte, or red blood cell, that mysterious cell that has no nucleus and does not reproduce. Yet it is found ubiquitous throughout our body. If we consider the diameter of a typical erythrocyte, about 10 microns, The number of bits of information that can be stored on an isosphere bounding such a cell is 10 to the 60th bits. By comparison, the National Security Agency's Utah Data Center has a reported capacity of a mere 10 to the 18 bits of information. One final piece of the Pribram-Bohm topology concerns the inclusion of time into the equation. How does the Planck time influence the proposed holoflux process? Using John Wheeler's famous self-observing U, an image he often used as shorthand to indicate the cosmology of the universe viewing its own creation, this slide expresses the fundamental clock cycle of the cosmos to be the Planck time of 10 to the minus 44 seconds. The implications here are enormous. We can only begin to imagine the cosmos as we know it operating at such a clock cycle. Imagine the entire plenum of galactic matter collapsing in and out of the explicate order at a rate of 10 to the 44 cycles per second. To summarize the Pribram-Bohm topology, we have here overlaid the image of an iris at the boundary of the implicate-explicate order. We see consciousness from within the quantum black hole at the left, looking out from the non-local implicate order into our local space-time explicate order. In such a topology, space-time is understood to be a projection out from the implicate order. Pribram summarizes his thinking here at the age of 94, and I quote, "These two domains characterize the input to and output from a lens that performs a Fourier transform. On one side of the transform lies the space-time order we ordinarily perceive, Bohm's explicate order, and on the other side lies a distributed and folded holographic-like order referred to as the frequency or spectral domain, Bohm's implicate order. What might be the implications of the Pribram-Bohm theory, particularly for consciousness studies, paranormal research, and non-dual experience? The implications are that consciousness, the experience itself, is not an epiphenomena of nerve impulse-powered neurons. But instead, if we follow the lead of Pribram and Bohm, consciousness should be regarded as primary, as radiant energy operating lens-like to focus and tune between the frequency domain and space-time. And what might this imply for a human physiology of consciousness? Where should we look then to identify structures within the human body capable of channeling high-frequency consciousness information? First, let's review the basis of electromagnetic communication. The fundamental process involves an antenna. Classical antenna theory holds that for maximum sensitivity, the physical antenna must be 1/2 of the wavelength. For example, an iPhone antenna transmits a wavelength of 6 inches. Its internal antenna is physically 3 inches. And the human ear, as an audio antenna, peaks at a wavelength half the size of the ear hole orifice. But actual radiation is complex and two-dimensional. Cartesian line graphs are misleading. In three-dimensional space, we must visualize waves of nested spherical energy moving out from the antenna at the speed of light. Here are 3 different ways to visualize radiation. At the bottom, we see a waveguide. The dimension of a waveguide acts as a cutoff that channels the wave and shields it from interference. If the human capillary system acts as a waveguide, its dimensions are optimized for 10-micron radiation and provides a capillary network stretching for more than 59,000 miles within each human being. And this image from a medical textbook shows the hollow ventricular cavities filled with clear cerebrospinal fluid. Medical textbooks say that the only function of these cavities is to help cushion the brain from impact concussion. But does it seem plausible that such beautiful streamlined shapes, so much like microwave horn antenna waveguides, should have evolved in the center of the cranium merely to cushion us from blows to the head? Coincidentally, perhaps, this X-ray taken from the front of the face reveals the shape of the ventricular cavities. Is it only coincidence that the ventricular cavities appear in the exact location depicted by occult illustrations of the third eye in Egypt, India, and China? Now, if the theory is that thought involves tuning the electromagnetic frequencies of the brain, the next question is, where should we look for frequency bands in which we might tune? What are the various ranges and bandwidths for human consciousness? Here we see 8 possible bands of resonant structures within human physiology. At the higher frequency end, we see microtubules as waveguide candidates at ultraviolet frequencies. Lower frequency bandwidths may be found in blood capillaries and neurons, which offer better waveguide performance in the lower infrared band. The proponents of quantum brain dynamics, the Japanese Mari Jibu and Kunio Yasue, have proposed that the combined electric dipoles of all the water molecules in the human bloodstream constitute a single quantum field referred to as the cortical field. To the left is a model of the magnetic field generated from one dipole of a water molecule. To the right is depicted a combined molecular dipole structure that may actively resonate within a narrow band of frequencies in the far infrared. Now let's examine a small band of the electromagnetic spectrum, from radio to gamma rays. Recall that as the size of the wavelength gets smaller, the frequency increases. The relationship is reciprocal. But here we consider this in the context of the entire frequency spectrum of the universe, ranging from a wavelength equal to the diameter of the known universe, at 10 to the plus 27 meters, down to the Planck length of 10 to the minus 35 meters. Here we see a typical modern transceiver used both to receive and to broadcast electromagnetic energy, but only within a very small range of the vast electromagnetic spectrum. And here we see a human transceiver, Pribram's holonomic brain, which, if our hypothesis holds, is tuned to the infrared band, just below the visible light frequencies. Human infrared frequency thus peak at 33 tetrahertz, much higher than radio frequencies, and this offers rich information processing capacity. But what evidence do we actually have that human consciousness might operate in the infrared? First of all, humans glow with infrared frequencies. With an output of about 860 watts, the human body is easily visible in the dark, using night vision goggles tuned to the infrared spectrum of electromagnetic energy. As you can see in the temperature scale on the right, temperature is directly proportional to electromagnetic wavelength, according to Wien's law, which we can use to calculate the maximum wavelength radiating at a specific temperature T. Applying Wien's law at various body temperatures, the bandwidth of human infrared can be established, and predicted to lie within 9.1 to 9.8 microns, in the 32 terahertz frequency band. In terms of power, each human heartbeat radiates 1.3 watts of infrared. An iPhone transmits 1.6 watts. The most powerful radio on the planet broadcasts 1.5 million watts. But by contrast, the combined output of 7 billion human heartbeats is an astounding 9.1 gigawatts broadcasting into the Noosphere. And where might the Noosphere be? In this graph, we see temperature at various distances from the ground. Notice how temperature at first decreases quickly as we rise in altitude, but for reasons not well understood, it increases sharply above 90 kilometers. At 100 kilometers, it passes through a zone that mirrors human body temperature at 37 degrees Celsius. Could cavity resonance in the thermosphere be the locus of what Teilhard de Chardin and Vladimir Vernadsky call the Noosphere? The atmosphere is opaque and blocks radiation at most wavelengths. However, this plot reveals major passbands in atmospheric capacity. As we can all attest, nature has evolved human organs of perception for this passband, which we call visible light. But what about the distinct passband shown here at around 10 microns, the human infrared range? What organs of perception might nature have evolved to take advantage of the passband at 10 microns? Could this be the doorway to regions explored by mystics, yogis, shamans, and saints throughout history? In closing, I would like to share a relevant quote from my good friend, mentor, and fellow explorer, Brian Swim, who has often said, "Radiance is the primary language of the universe." Thank you so very much for allowing me to share my ideas with you here today.